Okay, so now we're going to go over an example of how we can find the derivative of an inverse function. So for that, we're going to use this theorem, which says that if we have our function f and we define the inverse function of f to be g, then the derivative of g is equal to 1 over f prime of g of x. So again, we're saying that g of x is the inverse of f. So g of x is the same as f inverse. So in other words, you can say that the derivative of f inverse of x is equal to 1 over f prime of f inverse of x. So I wrote it both ways because it's common for textbooks to have the inverse function defined as g of x, but it really doesn't make a difference. But don't let it confuse you. Sometimes I know the notation can confuse you and make it seem like it's a completely different thing. I actually do prefer this way, but I just want to make sure I show that too. But anyways, let's go over an example. So let's say we have our function f being equal to 1/4 x cubed plus x minus 1. And we're going to find what the value of f inverse of 3 is, and then what the derivative of the inverse function of 3 is. So let's first look at A, where we have to find f inverse of 3. So remember what the inverse function says, meaning that we want to find what x value gives you an output of 3. In other words, we're looking for the x value that solves this equation, or rewriting that solves this equation. 3 is equal to 1/4 x cubed plus x minus 1. Now, this is usually how you would go if it's hard to find the equation of the inverse function, because there are going to be a lot of functions that finding the inverse function is not really simple. It's not like going to be simple algebra or arithmetic. You got to, do a lot of stuff. Likewise, sometimes it's harder to do it this way. So again, it just depends on the problem. So we want to just solve for x in this equation. And there's not, again, this is a cubic function. It's not going to be like a simple formula. So this is just going to be kind of like a plug and chug. So, but I gave a bit basic examples just so that we don't get hung up on that part. So again, if we're solving, we can add 1, get 4 equal to 1/4 x cubed plus x. Multiply everything by 4, and we get 16 is x cubed plus 4x. And then furthermore, we can maybe go and set 16 equal to x times x squared plus 4. And when we can see from here that if x is 2, then we get 2 times 4 plus 4, or 2 times 8, which is then 16. So that means when x is 2, f of x is 3. So vice versa, the f inverse of 3 is 2. So let's write that f inverse of 3 is equal to 2. Okay, so now what's the derivative of the inverse function of 3? So for that, we're going to use this equation here. So let's have that the f inverse of 3, so let's replace x with 3, is equal to 1 over f prime of f inverse of 3. Now, we found what f inverse of 3 is, which is 2. So then we can rewrite this and have that the f inverse of 3 is equal to 1 over f prime of 2. So now all we have to do is find the derivative equation of f of x and then evaluate it at 2. So let's find what f prime of x would be. So f prime of x would be 3 times 1/4 x squared, or 3/4 x squared, plus 1, and that's it, because there's the derivative of -1, 0 goes away. And then f prime of 2 will just be 3/4 times 2 squared, or 3/4 times 4, plus 1, which is just basically 3 plus 1, because these 4's cancel. So you get 3 plus 1, and so you get f prime of 2 is 4. And so then this just becomes 1 over 4. And there you go. That's all there is to it.